Hello students, today we'll discuss an important question that may be asked in your CBSE exam. So here you can see that the force experienced by unit charge when placed at 0.10 meter from the middle of an electric dipole on its axial line is 0.025 Newton, and when it is placed at 0.2 meter the force is reduced to 0.002 Newton. So calculate the dipole length. So from any question first we have to make a mathematical modeling. So here what are the parameters given? First case, here F1 is given as 0.025 Newton and R1 is given as 0.10 meter, and in second case here F2 is given as 0.002 Newton and R2 is given as 0.2 meter. So from this question we can understand that the electric field intensity at the axial line of an electric dipole is considered, and the force experienced by a test charge, in this case the test charge is equal to your 1 unit, so the force will be equal to the electric field intensity at that particular point. As we know, F is equal to Q into E, so Q, the test charge which is placed at that point, that is 1 unit, so this force will be equal to the electric field intensity. So we can find out the E1 for the first case. For the first case, the E1, so the formula will be on the axial line. So axial line, the formula is equal to, we know, K 2P upon RQ, and other formula is here, that is your K 2P R1 upon R1 square minus A1 square whole square. So in second case, the E2 will be equal to similarly K 2P R2 upon R2 square minus A2 square whole square. Here we can not use that 2P upon RQ because A is not very less than R, or it is also not given, that is it is very small compared to the R. So we will be using the full formula. So now dividing by this and dividing by this, what we will get? We will get this one as, here you can see E1 upon E2. So in this case for E1 we can write F1, as already I have discussed, that F is equal to Q into E. So here Q naught is equal to 1, so the F is equal to your E. So F1 by F2, so as per the question we can find out here 0.025 upon 0.002 will be equal to, here this will be cut, so we'll be getting R1 by R2. So R1 is here 0.10 divided by this is 0.2 into here this reciprocal, so this will be as the numerator and this will be in the downward. So this will be R2 square minus A2 square. So this is R2 square minus A2 square upon, so in this case this A is same, so we can consider as A only. So this is your A square, and this will be this one is R1 is equal to 0.1 square minus A square, so total whole square. So now you can calculate this one. This will come as 25 upon 2. Here this will be 1 by 2. Here we can take, this will be 0.04 minus A square divided by, this will be 0.01 minus A square whole square. So here it is cut. So if we take the square root, so this will come as 5. So 5, this will be 0.04 minus A square upon 0.01 minus A square. Now we cross multiply, so this will get 0.05 minus 5 A square will be equal to 0.04 minus A square. So again we can shift this one to that side. So this will be your 4A square will be equal to, this is 0.05 minus 0.04, so this will come as 0.01. Here we can take again this A square will be equal to 0.01 upon This will be your coming as divided by 4. Again, what will be your a square? A will be equal to square root of this. So square root of this will be 0.1 upon 2. 0.1 upon 2, this you can understand. This will be 1 upon 20. So this can be 0.0 and this will be 5. So this is your value of A. But in the question it is given to find out the dipole length. So you know, in this type of expression the length of the dipole is 2A. So length of the dipole is 2A. So here we can consider that length of dipole will be 2A. So this will be 2 into 0.05. So this will come as 0.10 meter. So this is your final answer. So in this question you have to understand that the force experienced by a charge when placed in a electric field, this will be equal to Q into E. And in this question the Q naught, that is the test charge, is given as unit charge. So we can consider that the force is equal to the electric field intensity. And the formula for the electric field intensity will be using the axial line, the electric field due to a dipole on its axial line. So this is your K2PR upon R square minus A square whole square. So the same formula we have used and we have taken the reciprocal, then finally we find this answer. So you can understand this one. This is a good question and conceptual based. So you should prepare for your exam.